From that right now, because we got to know the rules and we got to start stringing them together. And I think as you start proving them, the rules will start to make sense themselves, especially since we spent a lot of time in the beginning talking about our expansion. Okay? So for the 3 rules we're going to look at today, we're going to first start off by expanding it and try to make sense of what the rule says. Then we're going to practice a little bit, go to the next one. So guys, everybody here, we have to be ultra focused on what the rule says and just applying it then and there. Because we're going to skip through it pretty fast, all right? And at the end, if we have time, there will be some mixed practice so that you guys can get comfortable identifying which rule we see and then going off of that, okay? So let's take a look at the first one. Here I have p to the 5th power divided by p squared. So again, for me to see this rule, what I'm going to do is I'm going to expand this out. I'm going to expand the numerator and the denominator just like this. So the numerator is p to the 5th, that's p times p times p times p times p, and then p squared is p times p. From here, if I'm trying to simplify, how do I simplify this fraction? Be careful with how you answer that. How will I simplify this? Start.
Since you divided 2p with the bottom, don't the p's cancel out?
Good. So p's on the top, that's on the bottom, will cancel out. Because I know that p divided by p is equal to 1. Because the p's are going to cancel out. And when I cancel, I'm left with 1. Okay? So what I'm doing here is I'm going to cancel out the p's on the top and the bottom until one side is completely canceled. So I'm going to get rid of this p, and notice how I'm doing it. I'm going one at a time. And then I'm canceling this p, and I'm canceling this p. One of the parts of the fraction, the numerator and denominator, is not fully canceled. What I'm going to do is I'm going to put 1 there. Or I could just leave it, to be honest. And what am I left with? Like, p. Yes.
And then again, like this, once you your p's will cancel out, and then you can subtract your exponents, right? I agree.
I said, what's the answer? P. Now, what if I have this? I should have wrote this one before. Find space. What if I had 8x to the 3rd over 2x squared? Let's first expand it. The numerator expanded out would be what? Stefan?
8 times x times x.
The denominator would be what? Rashad?
2 times x times x.
Now, what do we have to do to simplify this? What happens here, Brent?
You divide 8 by 4.
Divide what?
I mean 8 divided by 2.
8 divided by 2 turns into what?
4.
Okay, so what I'm going to do here is I'm going to get rid of this 2 and put a 4 there. Because 8 divided by 2 is 4. Okay, good. And then what else happens? What else happens, Mike?
Then you cancel out the
Good. Cancel that x with that x. Then I'm going to cancel this x with this x. What am I left with? 4x. That's your second rule. It's called dividing like basis. Who thinks they can tell me what the dividing like basis rule says? There's 2 things that we have to do. What do we have to do?
First, you have to divide the coefficient.
You guys can second meeting.
Second, we have to cancel out the x.
What we cancel the x is what does that do? So canceling it tells me how it works. But what do we have to do?
We have to eliminate the. I don't want to say it, but I know what to do.
How do we show that? What do we have to do with the exponents?
Writing out the subtract.
We subtract.
Yeah.
Just like what you said earlier.
Oh yeah.
So the canceling is showing you why it works. What's happening is I'm taking away common ones, which means I'm subtracting. Make sense?
Yeah.
So that rule algebraically says x over x to the a over x to the b is just x to the a minus b. But if I have a coefficient out front, two things are happening. One, I'm dividing the coefficients. Or I'm simplifying. So like if I have like 4/6, I can cancel the 4/6 to become 2/3. So I can simplify that, or I'm dividing it. Because you can also technically have a decimal. I usually prefer to just divide and simplify there. But I'm dividing my coefficients, and I'm subtracting my exponents. It's almost the exact opposite as multiplying by bases. That's it. And the reason it works is because we're canceling out variables that are both the numerator and the denominator. And if we have a fraction, that means we're dividing. Canceling is how we simplify.
Let's say
Minus b, sorry. So we should be able to go keep this practice rapid fire. So j to the 9th over j to the 4th will be what, Bernie? Go ahead, j to the 5th. 9s to the 6th over 3x to the 4th should be what, Michael?
3x to the second power.
Take a minute. I want you to try to see through. Go. Try to see through. Just go piece by piece. If you have multiple variables, you just got to go piece by piece. Go.
These are your notes from last week. You do 9 divided by 3. Those are 9 here and 3 are coefficients.
Yeah.
Then for your like bases, for s's, those exponents you subtract.
Yep. So go piece by piece, guys. Start with your coefficients, then go variable by variable. They have to be the same. Writing this stuff down, or just... I wonder if I can.
I got 6 x's on the top and 5 x's on the bottom, so they all cancel. So I shouldn't have everything flush out for the x. X to the first.
It don't matter.
Careful with this one. 10 divided by 2 is not 10.
1, yeah, to show you.
Yeah.
Oh, yeah.
Change that.
Yeah,
So,
that one.
You gotta multiply, x to the 1, x to the 10, x to the 7.
So for my x's, that's right, because I have 6 up top and 5 on the bottom. So I cancel out 1 x out. But then for my y's, I got 2 y's up top and I got 1 y on the bottom. So how many y's are we left when I cancel? So
X
x is the
is
first
one
one.
at the top and the bottom. Right, but when you cross them off, they're on the top. So when the X is here,
To the first,
X,
y to the
so it's
third.
actually.
So how many x's do you have up top?
2.
I have 7 x's. X to the 7th is how many x's? Okay, and then I have x to the 4th, which is how many x's? So how many x's in total do I have up the top? Okay, and then how many x's do I have up the bottom? So then when I cancel those out, how many x's?
Basically 8 divided by 2.
I mean, you said cancel it out.
Cancel.
Well, that would just. we'll know.
So I have 11 up top and 6 on the bottom. So when I cancel,
And then type it to your function.
you see what I'm
So
saying?
it'd be x to the fifth.
X to the first.
Y to the fifth.
All right, let's take a look. And guys, the biggest piece of advice I'm gonna give here is that, guys, you gotta go piece by piece. Okay? You gotta start with your coefficients, because if I could get rid of those numbers or make that number look a little bit less scary, That's gonna help me out. And then I'm going variable by variable. So you gotta start somewhere. Look at your x's, subtract. Look at your y's, subtract. Because as they get more detailed, that becomes all the more important so that it gets simpler. Because part of this is that we have an expression that's more simple than the one that we had to begin with. All right? So for C, 8x to the 6th over x to the 5th is what, Rashawn?
8x.
Good. Now y'all say 8x to the 1st if you want to use that rule, but you got to visualize it. I got 6x up top and 5 on the bottom. If I'm canceling, I'm going to have 1 left. All right? So that's how you got to think about it. We can't sit and expand everything. So in the meantime, we got to expand in our heads. Say, well, x to the 5th is 5x. I'm sorry, x to the 6th is 6x's. On the bottom, I have 5x's. I'm getting rid of them. I have 1 left. All right? What about D? Kyle?
0.5x to the third.
I accept that. The other way I would accept also is this. So where did the 0.5 come from?
So the 0.5 came from, you can't do 20 divided by 10, you have to start with your number. So I did 10 divided by 20, and they got me 0.5.
Good.
Then 7 minus 4 is 3.
Good. So if you're going to divide the like bases, that's just 10 divided by 20. The other way you could say is just 1 over 2. Because 10 over 20 is equal to 1 over 2. And then you subtract. But the thing here, though, guys, you got to be careful. So I want everybody to write this part down. Because if I'm subtracting here, and I still have my fraction, 7 minus 4 is 3. That x has to go to the numerator. Okay? When we go over negative exponents, you're going to realize why it has to be in the numerator. But right now, it has to be in the numerator. All right? So I would accept this, or even this, because you actually don't need the 1. You can say x to the 3rd over 2. Any of these would be acceptable, but on a test, you're going to see this as the correct answer. So write these 3 examples down so you know how to recognize the correct answer from the test. It'd be this. Because in here, I got rid of the 1, because it's the coefficient, and then I just simplified 10 over 20. E, Rashawn.
I don't know if it's right now, but I got XY.
Good.
All is right?
6 minus 5 is what?
1.
So that's x to the 1st, and then 2 minus 1 is what?
2 minus 1, 1.
Good. The thing I'll say here, though, guys, what throws us off, that y is essentially y to the 1st. So if you need to put a 1 here for subtraction purposes, do that. Because a lot of people say xy squared, because they're going to forget that 1's there. So don't make that mistake. And then lastly, here we have to add a step. Okay? But if we start with our coefficients, what happens with our coefficients, Vernon?
They cancel out.
Good? Because they're both 10s, right? So now, what do you see from here? Because you got to be careful. It's a little bit different here. What do you see now, Ariana?
Can't you, for the first 7 x's in the first 6 x's, cancel, like, those cancel out?
You could.
Y to the 3rd, and then x to the 1.
Hold on. If I cancel x to the 7th over x to the 6th, what am I left with?
So, it'll be 1 left.
So be
X.
good. Hold on. Hold there. If I cancel 7 minus 6, that leaves me with x. So now I have an x, I have y to the 3rd, and I have x to the 4th. Now what rule do you see that's going to help you finish this problem? Kendra, what do you see? X, y to the 3rd, x to the 4th.
Oh.
What can I do with this? It's written out already. Guys, as we start going through these rules, you got the successful students here can see the rules. You got to see the rules. We've looked at 2 so far. What rule do you see here? Mike?
Like 10? You do
Like what?
like 10.
Like?
Like this?
There you go. We got like bases. So what do we do with like bases? You add them. So what are we adding here? What exponents are we adding?
X.
This x and those aren't like bases. You should have like bases. They're not like bases. Vernon?
For that one, I just added the, when you started off, I said the seven.
We're here now.
It's extra.
Where's your X from the fifth from?
You added.
Oh, yes.
Good. Guys, if we need to expand here, if we need to expand, we do that. Here's an X times Y times Y times Y times X times X times X times X. How many X's do I have? Kyle? 5. X to the fifth, Y to the third. So guys, I put that example there because we got to start blending in the rules. I'm not going to just give you isolated rules of exponents. You're going to get 2 or 3. Some of you guys will be able to solve all 6 in one. Yeah. But you got to see the rule. If I see like bases, I'm not satisfied with leaving them there. All right? Questions there? All right. Now we're going to take a look at the next one. I think the next one pretty straightforward because we saw some success with the expansion here. If I'm going to expand this y cubed squared, what would that look like, Dante? Y, so say y times. Good. And then what? So what does that mean? When you say you gotta do that, do 2 inside, what does that mean? Okay? Just y times y? So I help them out. Because you're close. I know we got the y times y from. I got y times y times y. What do I have to do from there, Dimitri? Do it again. Why?
Because we should have y times 1 is 2 it does.
Good. That second exponent, that 2 says, whatever's in the parentheses, I gotta write it twice. Inside the parentheses, I gotta write y 3 times. Y times y times y, y times y times y. This will be what? Mike? Y to 6. Here's your third rule. What does this rule say? What do you think the rule says? That's correct.
X, A times B.
Good. This rule is called an exponent or power of a power. And all it's saying is, if I have a power that's subjected to a power, we're going to multiply them. X to the AB. Now notice, this is similar to, or it looks similar to multiplying like bases. But it's not the same. So I'm going to actually put a couple examples up here that I want you guys right at the bottom so that you know the difference between the two. Because this is where the confusion hits, whether to add or multiply. So, who can give me the simplified version of either of these? Top or the bottom. Because this is where all your misconceptions are going to come between this rule. Terrence, give me one. X to what? Y.
8.
Y. Y.
That's like 4. I mean, I'm like 1x. So you do it like 1.
Good. There's 4 X's.
Or you can
Do
do
that.
that.
No, but you said 6 first, so we got to expand it out. You didn't.
No, I ain't touching.
You didn't try to, but you didn't.
No, put it on the bottom.
So that's x to the 8th. X to the 4th squared is x to the 8th. What's the bottom example? Michael?
Then it's X,
Why?
because you adding 1.
Why?
You doing X plus X.
Not plus, but times. This example here, I think, can show you clearly the difference between the two. Write this down at the very bottom, guys, of your notes right now. Because all the common mistakes when it comes to multiplying like bases and exponent of exponent are going to come with how they're worded. What do you see as the difference between the two in terms of how they were written? Or what's going to tell you multiply versus add as a visual cue? Right. okay? The bottom one doesn't, what else?